So now we're going to look at a more complex calorimetry problem. How do we know this is more complex, one might ask? Well, I just said it's more complex. In addition, there's a couple other clues that it's more complicated. We're told that we need to find the heat capacity, so that clearly indicates that the calorimeter is absorbing some of the heat of the reaction, and this calorimeter has a certain amount of water in it, and there's a combustion reaction going on. So each of those three underlined or highlighted things sort of suggests that there are not two terms, ooh, look at the shadow, not two terms going on, but rather three Q terms going on. So when we write our Q reaction, or our Q equation, we're going to have, oddly enough, three different things. One of them is just going to be the water heating up. One is going to be the Q combustion reaction that we have at work here, burning, what is this, benzoic acid. And the last thing is going to be the heat that the calorimeter is absorbing, which is indirectly one of the things that we're going to end up finding. So Q calorimeter. So we now need to think about what to plug in for each of these things. Okay, Q water is fairly obvious. It's going to be an MCAT situation, right? Because we know the mass of the water and we know its temperature change. Q combustion, again, this is a reaction. It's a process. The benzoic acid is not the same at the beginning and at the end. So we can't plug in CAT or MCAT for this. So instead, we're just going to keep it as Q reaction, Q combustion. Q calorimeter is going to be heat capacity times the change in temperature. So I think we can now get to actually solving for some of this stuff. 0 equals, the mass of water is 900 grams exactly. You all probably have this number in your head, 4.18 joules over grams times degrees Celsius. What's our temperature change here? Okay? By the way, the words by versus at are often confusing to students. Or by at to, by meaning that's a change in temperature. It's not just a starting temperature or final temperature. Okay, so anyway, point of all that verbiage, 8.32 degrees Celsius plus our Q combustion thing. Okay, so I believe we're given the delta H for the reaction, and we know how much of benzoic acid we have here. So negative 3.227 kilojoules per mole. And actually, sorry, I should have started off by writing 1.90 grams of benzoic acid. So now I need to do something where we go from grams to moles. In other words, we need to do a really simple stoichiometry conversion here. So the molar mass, so we have 1 mole of benzoic acid on the top, and we have the molar mass of benzoic acid on the bottom. I don't feel like calculating that, so C6H5COOH, 122.12. So, all right, so 122.12, I think is what I said, grams. Last thing, times times big C, what we're trying to find, times our change in temperature, which is the same as the change in temperature of water, because the container is what's actually holding the water. So when we solve for all this stuff, what we get is C equals 3750, is this the wrong layer? 3755.97. Okay, that seems awfully big. 900 times 4.18. Oh, make sure that when you are doing the conversion, you pay attention to that thing I mentioned previously in class and on another one of these, joules and kilojoules. I actually just did the calculations the first time and I screwed it up because I didn't do the conversion. I'm going to try it again. So I get C is equal to 2.27, 2.27 kilojoules per degree Celsius. And notice, again, just to beat on a dead horse, kilojoules, not joules, because I decided to turn this up here into kilojoules. Quick sig fig check. Yep, it makes sense to have 3 sig figs for this problem. So there it is.